Okay, good day Year 12. What we're going to do today is going to use backward scanning to determine the latest start times and the float times for each activity in a network. We can also reflect on the critical path on each network as well today. So some important terminology that we want to start off with is, first of all, is the latest start time. I'll often just abbreviate that as LST. And that's the time at which an activity may be started for the project to run on time. The float time is the maximum time by which an activity can be delayed. So that's generally the latest finish time minus the earliest start time minus that activity time. Backward scanning is when we begin at each node and work backwards. We subtract the time from each arc from the latest start time of the next node. Now, the latest finish time for an activity is the same as the latest starting time of the following activity. So the late times are on the right-hand side. So that's our latest start time for X, but this will be our latest finish time. Sometimes we call it latest completion time for W. And this will be in the right hand side of the node. And the critical path is the path at which no activities can be delayed. So if you delay that activity, it delays the whole project. Now that will be when both sides of the node are the same. So if I have an early start time and my latest start time, they'll have to be the same for activities on the critical path. In this activity, I want to work through an exercise that you'll see in the textbook. So this is an exercise 9B. I've just stolen it from your textbook. So I'm going to do a forward scan first of all to find our earliest completion time, and then I'm going to do a backward scan to look at our critical path, and we can talk about float times and so on. So we start off at 0. So the first node will be 0. Now A is 7, so we go 7, and B is 11. So 7 plus 11 is 18. 18 plus 3, well, that's 21. And 21 plus 6 is 27. What I'm going to do is just put a little note above there to see this path, how long it takes, or how much, what the value is. Now, if I look at the bottom path, 7 plus 4 is 11. And then 11 plus 12 is 23, and 23 plus 8 is 31 coming in here. Now, if I delay activity G, I'm going to delay the whole project. So this tells me that this is the critical path. So what I can do then is, and I'll get you to do this in your test, you get a highlighter and you just color in the critical path like so. So what you say is the critical path equals activity A, oops, and then we'll go activity C, activity E, activity G, and then in brackets we will just describe how long that is. So if it's 31 minutes, we'd write 31 minutes, for example. So this is our critical path. It's highlighted. Each of these are our critical activities. And that's what we learned last lesson, and that was called forward scanning. What I'm going to do now is move on and look at backward scanning. So we start at the back. Now, the two numbers at the back are the same. So 31 and 31. Let's see if this one stands out a bit better. So then we work backwards. Now, each of these on the critical path are going to be the same value. So the earliest completion time for E, or the earliest start time for G, is going to be the same as the latest start time for G, or the earliest completion time for E. So let's just remember that this side is early, this side is late. It's the earliest completion time for E, but the earliest start time for G. On the critical path, both of those are going to be the same. So that tells me that that's going to be not 12, 23 take 12 is 11. And then 11 take 4 is 7. 7 take 7 is 0. But let's have a look at the other path now. So 31 take 6 is 25. Now we can quickly see that we've got a float time here of 4 minutes. So I can say 25 take 21 is 4, and so I can delay F by 6 minutes if I have kept up to speed with the other two activities here, both B and D. Let's continue. So 25 take 3 is 22. Now this one's already completed because activity A is on the critical path. Let's have a look at another network. We're going to forward scan for the earliest completion time, and then we're going to backward scan for the latest completion time. Then we'll look at the float times and critical paths as well. So let's draw some lines down the middle of our nodes. So I'm just going to do this first of all. So remember, on the left hand side of our node are the early times, and on the right hand side are our late times. We forward scan to fill in the left hand side or our early times. So we start at 0. Now 0 and 5 is 5, 0 and 4 is 4. So I've gone to the first nodes out. Now I'm going to go to the second nodes out. Now 4 and 5 is 9, 4 and 8 is 12, 6 and 5 is 11. Now the bigger number is the important number here, because if I delay D, I delay the whole project. So that's going to be a critical activity. So I know pretty well straight away that this part is critical. Now let's continue. So 12 and 3 make 15. There's only one thing into there. And now I'm into the final part of my network. I'm going to list what comes in to the final node. So 15 and 5 is 20. 12 and 7 is 19. And is that a 9? That must be a 9. 4 and 5 is 9. I'll correct that better. That's a 9. 9 and 6 make 15. I choose the bigger number because if I delay that, I delay the whole activity. And there we go. So I know that this is also on the critical path, and this also must be on the critical path. Now remember, with the critical path, both the sides of the nodes must be the same. So that's pretty nice to determine straight away. So that's going to be 20. Let's just look at that. 20 take 5 is 15. 15 take 3 is 12. 12 take 8 is 4. And 4 take 4 is 0. That's our critical path. If we want to finish the rest of the network diagram, we can also consider float times. So 20 take 6 is 14. Now I've got a float time there of 14 take 9, which is 5 minutes. That means I can delay until 14 minutes after the start to start activity F. So this is my float time, is that 14 take 9, and that'll be helpful for you later on to consider. Let's also look further up here. I have a 12 take a 6, that's 6. So the difference between those two is 1 minute. So that's nice to know. We have a float time of a minute there. Okay, finally seniors, there's a revision example here for you, and you can have a look at the example and the answer there. Now your work is to do exercise 9B, and there's not too many there, so you can do the whole exercise.